This recording will discuss the presentation PowerPoint materials for Chapter 3. Chapter 3 is focused on solving applied problems. In Section 3.1, you focus on translating English phrases into algebraic expressions. So here is an example. If we use the words greater than, increased by, more than, added to, or sum of, we know we're adding. These are the terms that are represented with subtracting. If we see multiplied by, of, product of, or times, we see a multiplication sign, and divided by, ratio of, or quotient would be division. All of these phrases are representative of an equals sign. So here are some examples if we were to write this phrase as an expression. Remember, an expression does not have an equal sign. An expression may be written for several quantities using the same variable. Here is an example using the letter A to write an algebraic expression for each quantity. Twice as many books. Nancy read twice as many books as Andy. Marty read 5 more books than Andy. So using A to represent the number of books Andy read, we can write two different expressions that show us those two sentences for Nancy and Marty. Here's another example of writing an algebraic expression starting with what we're going to set our variable to. In the next section, we're using those equations to solve some word problems. So first we need to read the problem and understand what information is important. It helps to draw a sketch or label the information, choose a variable to represent your unknown quantities, and figure out what information you know and what variables you need to solve for. Look for keywords to help you and look for relationships. And when you're finished or you've reached a solution, check and make sure it makes sense. Here's an example. 12 more than a number is 72. What is the number? You can let x represent your unknown number and write an equation. 12 more than a number is, and you can see x plus 12 equals 72. Solve. We end up with 60, and check your work, and it does work out. Here's another example. See how first you represent the variable, write an equation, solve, and check your work. Here's an example with a story problem. A golf course in Florida has a perimeter, or the distance around, of 92 miles. The course is in the shape of a rectangle. It might help to draw a picture here. The length of the course is 30 miles, less than triple the width of the course. Find the length and the width of the golf course. So first let's understand the problem. We'll let W equal the width. 3 times W minus 30 equals the length. And to find the perimeter, I would add up all the sides. That's 2 widths plus 2 lengths. I can write an equation. 2W plus 2L equals 92. I can substitute what we know for L. 3W minus 30. I can solve for W to get 19 and check my work to find the length. I can put both of those values in to check my solution. Again, one more example of how we can break apart a problem by representing a variable to understand the problem, write an equation, solve, and check our work. In section 3.3, you're focusing on solving word problems with comparisons. Here's an example. In a basketball game, the Vikings scored 12 points more than the Mustangs. A total of 78 points were scored. How many points were scored by each team? So first we want to understand the problem. Let M, our variable, represent the points scored by the Mustangs, and M plus 12 represent the points scored by the Vikings. By writing the equation M plus 12 equals 78, we can solve and state our answer. Here is one more example that is very similar. In section 3.4, you're solving word problems with the value of money and also using percents. We're going to use the same steps, except here we have money, decimal numbers. So let's find one with a percent. A sofa was marked down with the following sign: the price of the sofa has been reduced by 23%. You can save $138 if you buy now. What was the original price of the sofa? So we can let S represent the original price. Let 0.23S equal the amount of the price reduction, because as a decimal, 23% is 23 out of 100. 0.23 hundredths would be the way you would write that as a decimal. Then you can write your equation and solve. You will also find simple interest problems where I is equal to the principal times the rate times the time. And in time, we are referring to years. So if you are given a problem that tells you how many months, you just need to figure out of 12 months or 1 year, what fraction would that be of a year? So 3 months would be 3 out of 12, or 1/4 of a year. In section 3.5, you will be using word problems to solve geometric formulas. Here are some common geometric formulas for parallelograms, rectangles, squares, triangles, trapezoids, and circles. Some basic facts about triangles. We know the sum of all interior angles is always 180 degrees. In an equilateral triangle, each angle measures 60 degrees. Isosceles triangles, opposite angles are equal, and in a right triangle, we have one angle that is 90 degrees. You can use that information to help find areas of triangles in some of the problems within this section. Here are some examples. Surface area and volume are also mentioned in this section. Surface area is the total area of all the faces of a figure, while volume is the measure of the amount of space inside of a figure. Here are some common geometric formulas for rectangular solids, spheres, and right circular cylinders. Using those formulas and using values provided in examples, you should be able to replace the variables with the values given to find volumes of certain three-dimensional shapes. In section 3.6, you're using inequalities to solve word problems. Again, we're looking at those inequality symbols: greater than, less than, greater than or equal to, or less than or equal to. We want to start by translating each statement, and then you can use those translations to help write expressions to solve these problems. Here are some examples. The U.S. Postal Service provides guidelines for package sizes. One of the guidelines specifies the dimensions of the package. If you are preparing a package that is 33 inches wide and 28 inches high, how long is the package permitted to be? So you can let L represent the length of the package. You can draw a picture to help solve for the length plus the circumference cannot be greater than 130 inches, so you would have less than or equal to, and then solve for L. If you have any questions on Chapter 3, please email me.